In inverse Laplace transforms, we have the last two topics. That one is convolution theorem and apply Laplace transforms on differential equations. So let me see the first one, convolution theorem. Here convolution theorem statement is, if f of t and g of t are given functions, then the convolution of f of t and g of t is defined by f of t multiplication of g of t equals to integration of 0 to t f of u into g of t minus u. Just in place of t we have to write u, but whereas in g of t we have to write g of t minus u. That is the difference. That's it. And Laplace transform L of f of t into g of t is equals to L of f of t into L of g of t is nothing but L of f of t we know that f bar of s, and L of g of t is g bar of s. Some corollary, it one has the using above theorem we will get the corollary that L inverse of f bar of s into g bar of s is equals to f of t into g of t. That is equals to, what is f of t? We know that L inverse of f bar of s and g of t is L inverse of g bar of s. But whereas in problem we have to modify the given problem into our convenience purpose. That means this formula is actually applicable for the convolution theorem. In that one only we have taken L inverse of f bar of s into g bar of s is equals to f of t into g of t, and f of t into g of t we have to write here from integration of 0 to t f of u into g of t minus u du. Let me see the problem to make it clear. So using convolution theorem, find L inverse of 1 by s into s square plus 4. So this is the problem. In the question only, in the examination, in the question only he will mention that using convolution theorem to solve this problem. Then only we have to apply the convolution theorem. Otherwise we will go through the general procedure. If you mention convolution only, we have to do in this way. Okay. L inverse of 1 by s square plus 4. We have to write individuals. L inverse of 1 by s multiplication of L inverse of 1 by s square plus 4. And after that L inverse of 1 by s. Now we are forming this into the formula. So how this is in the formula, sin 80 formula, by simply multiplying divided with the 2. So here we have L inverse of 1 by s multiplication, multiply and divide with 2, 1 by 2 L inverse of 2 by s square plus 4 can be written as 2 square. L inverse of constant by s is constant. In place of constant we have 1. Multiplication of 1 by 2. L inverse of a by s square plus a square formula, sin 80. Now L inverse of a bar of s, L inverse of g bar of s. Finally we get in the form of f of t into g of t. F of t into g of t. Now we have to apply the convolution theorem formula, where f of t into g of t is equals to, here we have f of t into g of t is equals to integration of 0 to t f of u g of t minus u, f of u g of t minus u. Okay, now this is equals to integration of 0 to t. What is f of u? In place of f of t, f of u we have constant 1 into and g of t minus u. What is g of t actually? 1 by 2 sin 2 theta 2t, 1 by 2 sin 2t. In place of t we have to write t minus u, so t minus u. That's it. F of u is 1 into g of t, 1 by 2 sin 2t. In place of t write t minus u, in place of t write t minus u. That's it. 1 by 2 constant right outside, integration of 0 to t sin 2 of t minus u du. Now the simplification procedure, 1 by 2 of integration of sin 2 theta minus cos 2 theta by 2, minus cos 2, in place of theta you may assume t minus u by 2, and the differentiation of this one, this is not the single term, so we have to differentiate this one as a chain rule. T derivative 0 with respect of u, and minus u derivative minus 1. 2 into minus 1 is minus 2. Now 1 by 2 into 2 is 4, minus plus cos of upper limit minus of lower limit, t minus t is 0, 2 into 0 0, cos 0 is 1, minus cos 2t. So in this way we solved this problem by using convolution theorem. Okay, now let me see the another problem using convolution theorem evaluate L inverse of 1 by s plus 1, L inverse of 1 by s plus 2, e power minus t, e power minus 2t, integration, convolution theorem, integration of 0 to t, e power minus u into this is one is g of t. So g of t minus u we have to write. So e power minus 2 of t minus u, and simplify that, you will get the solution for here. And another important one, we have apply Laplace transforms for solving differential equation with initial condition. I mentioned that the second one after convolution. This is the last one we are having in the inverse Laplace transform. Apply Laplace transform for solving differential equation with initial conditions. So here we have some formulas. Laplace of second time derivative of y, s square y bar minus s into y of t minus y dash of t if the independent variable is t. If the independent variable is x, so we can write x. Okay, and Laplace transform of one time first order dy by dx is equals to s into y bar minus y of x. These two formulas you have to by heart. Now let me see a problem. Solve the differential equation using Laplace transform. Y double dash plus y is equals to 0 with initial condition y of 0 equals 0 and y dash of 0 equals to 2. Now given differential equation y double dash plus y equals 0, taking Laplace transform on both sides, L of now let me take individually L of y double dash plus L of y, L of y double dash plus L of y equals to Laplace transform 0 is 0. Now we have the already formulas. L of y double dash s square y bar minus s y of x minus y dash of x plus this is the second time derivative of y, L of y. Okay, and L of y can be written as y bar simply. Y bar, L of y can be written as y bar equals 0 equals 0. Now y bar of here y bar, take common, we got s square plus 1 minus y of x into s minus y dash of x equals 0. Now here we are going to use the initial conditions. What are the initial conditions in the given problem? We have y of 0 equals 0 and y dash of 0 equals to 2. Y dash of 0 equals 2. That means in place of x equals 0, y value 0. In place of x equals 0, y dash of x is equals to 2. Substituting it here, y bar of s square plus 1 minus y of 0 into s minus y dash of x equals to 0. Here x equals to 0 equals to 0. Now y bar of s square plus 1 minus, actually y of 0 value is 0, so 0 into s is 0 minus y dash of 0 value, we have y dash of 0 value is 2, so substitute here 2. Y bar of 2 equals 0, take constant here, y bar is equals to 2 by s square plus 1. Now taking inverse Laplace transform on both sides, L inverse of y bar equals to here, let me write L inverse of y bar equals to L inverse of 2 by s square plus 1. L inverse of y bar, here we are assumed that we can write it as let capital Y is equals to 2 right outside, L inverse of 1 by s square plus 1 and capital Y is equals to 2 into, this in the form of L inverse of a by a square plus a square is what? 2 sine 80. In place of a we have 1. So in this way we have to solve the problem. Taking Laplace transform on both sides, this one, take individuals, substitute formula, simplify it with the initial conditions. With the initial conditions, the value is 2 and here 0 into something is 0, and take constant here right side, RHS side, and after that, after writing y bar is equals to taking inverse Laplace transform on both sides, simplify it. So this is the procedure we have. So here we have two more problems. So this one and the solutions, here I'm going to show you the solutions of that one as. So here these are the solutions for the problem and you may practice it. So very important problems. Okay, may pass and check the problems, pass and write, and after that one you have these two problems. Okay, So this is the we have, and the next problems already we are having here. So let me check the problem. Conjunction theorem, yes. So this is one of the important problem. And this one too. Thank you everyone, practice it.